Greetings. On this video, I'm going to present desktop study undertaken for geological investigation for a proposed substation construction project in Spruit in Pretoria. This report detailed and comment on the result of an engineering geological investigation conducted for the proposed substation in Zwartkoppie. The aim of the study is to undertake geotechnical investigation in terms of the normal requirement for township proclamation, in which particular attention was devoted to the possible presence of problem soils, such as collapsing sand and settling clays, patched water table, and shallow bedrock. The information gained during the investigation was intended for substation construction project planning, as well as to enable design and construction precaution to be taken for like structures, thus reducing the risk for damages in those areas where such conditions occur. The nature of the project. The project comprises the construction of a new substation in the Spruit in Pretoria, Gauteng province. The development will include the installation of typical instruments such as power transformers, high voltage switchgear, instrument transformer, surge arresters, post insulators, steel structure, and foundations. Geology and soil. The geology of the area comprises mainly shale of the Magaliesberg Formation of the Pretoria group of Transvaal sequence. Some later intrusion of diabases occur as outcrop. The table below summarizes the formation of the soil and the geology of the area. Soil and problem soils. Sandy soil are present on the south side of the terrain, while the texture of the soil becomes more clayey towards the north. The transported soil have a good internal drainage. However, evidence of volume change due to fluctuation moisture content is manifested in well-developed structures such as wide and deep fissures and self-mulching surface. Problem soils give rise to many geotechnical difficulties, including inadequate bearing capacity, potential settlement, slope instability, and expansive. Clay expansive soil and rock clay were encountered. Laboratory tests to be carried out to identify soil properties, grading analysis, liquid limit, plastic limit, unit weight, density, specific gravity, moisture content, density relationship, compaction, California barrier ratio test. Expansive clay, cracking clays, and collapsible soils can be treated by soil stabilization techniques such as in situ stabilization, deep mixing method. Excavation. No problems are foreseen with excavation of the area except where hard rock outcrop occur at shallow depth below surface. The superficial and most of the residual soil are easily excavatable with slow penetration of the backhoe near the rock head. The overall excavatability for foundation and surface can be done with pick and shovel in the transported and residual soil, which classify as soft excavation by South African Bureau of Standards 1200. The shallow patched water condition, which can occur during the wet season, can cause trouble during the excavation of the foundation or surfaces. Compaction, soil erosion, and drainage. Compaction. To determine the compaction properties of the material underlying the site for construction or earthwork purpose, bulk samples were taken. The optimum moisture content and maximum dry density relationship was used to specify a standard degree of compaction to be achieved during construction. Soil erosion. The transported material over the site comprises mainly of silt sand. These materials are also of low plasticity, making them very susceptible to the water erosion. It is therefore likely that stormwater can cause serious erosion constraints to the development. Drainage. Care must be taken to drainage due to surface seepage, which is expected during rainy season. Slope stability. The areas proposed for development are anticipated to be stable. No adverse features were observed, which are indicative of landslide activity. Conclusion and recommendation. The greater extent of site of transported hill wash and lain at depth by weathered shade. Soil tests were done on disturbed soil sample from the representative soil horizon. The result of this test were utilized to determine the engineering properties of the various diagnostic soil horizon. The in-situ material can be used as fill and sub-base material. However, it is recommended that construction material be imported to the site to optimize the development potential of the terrain. It may be discovered that soil conditions at variance with those discussed in this report do occur in very small localized patches. We are, however, of the opinion that the soil are generally of somewhat homogeneous nature and little variability is expected, except in the hard rock profile variation. The proposed development is supported from a geotechnical perspective, provided that all the precautions and recommendations are presented in the report are adhered to. Thank you.